we'll start with alkalinity now. So this alkalinity is opposite to acidity. So acidity was caused due to pH ions, and it was the ability of water to neutralize base. So for alkalinity it will be opposite. So it is the measure of ability of water to neutralize acid. Okay. So this alkalinity is caused due to hydroxyl ions, that is OH minus, carbonate ions CO3 minus 2, and bicarbonate ions. So alkalinity in water is caused due to three things. First is hydroxyl ions, that is OH minus. Then second is carbonates CO3 minus 2 and bicarbonates is HCO3 minus. Okay, so these are the three main ions which are responsible for alkalinity. Now for the given pH range, which of these ions are present, that we will study. So this is an important point. When pH is greater than 10.2, when pH is greater than 10.2, then alkalinity is caused only by hydroxyl ion. Alkalinity is caused by hydroxyl ions, that is OH minus. And when pH will be less than 10.2, alkalinity will be caused. Alkalinity is caused by both carbonates and bicarbonates, that is CO3 minus 2 and HCO3 minus. Okay, if you want to go in detail in this also 10.2, then you can just remember this. If it is between 4.2 to 8.2, then it is only due to HCO3 minus, and if it is from 8.2 to 10.2, then it is caused by only CO3 minus 2. So if we combine this both, we'll get the together. Okay, we'll get both carbonates and bicarbonates together. Now the next point here is how to estimate the total alkalinity. So estimation of total alkalinity. So both acidity and alkalinity, we have seen that they are expressed, or they are to be expressed in terms of mg per liter of calcium carbonate. Mg per liter of calcium carbonate. So first we'll write down the main formula here. So the total alkalinity expressed in mg per liter of CaCO3, total alkalinity is equal to concentration of OH minus ions, and this has to be in mg per liter. Concentration of OH minus ions into equivalent weight of calcium carbonate, divided by equivalent weight of OH minus. Now you can see there are few terms like equivalent weight and valency, so they are going to come here. So that are the terms which are been covered in chemistry. Okay, So we cannot go much in detail in those formula. For now you can just remember these terms. Okay, so how to find out equivalent weight? Equivalent weight. So equivalent weight is equal to molecular weight divided by valency. Equivalent weight of any compound or any molecule is equal to molecular weight divided by valency. So we'll find out what is the equivalent weight of CaCO3. So it will be molecular weight of CaCO3. And what is the molecular weight of CaCO3? You have seen in the previous video. So it is molecular weight of CaCO3 is 100. So it is 100 divided by valency for calcium carbonate is 2. So how this valency has come? So for this you have to see which type of ion is present in this. So if you see this calcium carbonate, it can be dissociated into calcium plus carbonate ion, and this carbonate is having -2 and this is having +2 charge. So this +2 is called as the valency or -2. Okay, so this 2 is the valency here. This will be 50. Similarly, equivalent weight of OH minus hydroxyl ion is equal to molecular weight of hydroxyl ion, that is 16 plus 1 17 divided by valency is -1, that is 1 here. This is 17. So we can write down this formula, or we can summarize this formula as total alkalinity is equal to OH minus concentration into 50 divided by 17. Okay, where this will come in mg per liter. This we have to substitute in mg per liter, and this is constant 50 by 17. Now when to use this formula? When the pH value is greater than 10.2, because we have seen in the first point, if the pH is 10.2, then the alkalinity is caused only due to hydroxyl ion. Okay, so in this case we have, that's why we have taken in the formula only the concentration of hydroxyl ion. Now if the pH is less than 10.2, then if the pH is less than 10.2, then total alkalinity will be caused due to both carbonate and bicarbonate ions. So for second case, total alkalinity will be in terms of mg per liter of CaCO3. This is equal to, first we'll take carbonate. So carbonate ion concentration, this has to be in mg per liter, multiplied by same formula, equivalent weight of CaCO3 divided by equivalent weight of, here we are taking the carbonate ion, so equivalent weight of carbonate ion, plus second will be bicarbonate ion concentration, this also should be in mg per liter, multiplied by equivalent weight of calcium carbonate CaCO3 divided by equivalent weight of which ion we are taking here, HCO3. So you can see here the given concentration, we are converting it into concentration in terms of CaCO3. That's why we are multiplying it with equivalent weight of CaCO3. Now same process we will carry out here. So equivalent weight formula we all know now, we won't be writing it again. So equivalent weight of CaCO3, so this is 50. In the previous slide we have calculated. Equivalent weight of carbonate ion is equal to molecular weight of carbonate ion. So carbon is 12 and oxygen is 16. 12 plus 16 into 3, that is 12 plus 48, it is 60, divided by valency 2, so it will be 30. Similarly, equivalent weight equivalent weight of bicarbonate ion is equal to molecular weight of bicarbonate ion. So hydrogen 1, carbon 12, oxygen 16. 1 plus 12 plus 48, this will be 61, valency is 1. So equivalent weight of bicarbonate is 61. Substitute this all formulas in the first equation. So total alkalinity will be equal to CO3 minus 2 in terms of mg per liter multiplied by 50 divided by what is the equivalent weight of bicarbonate ion, it is 30, plus okay carbonate ion it is then plus bicarbonate ion concentration into equivalent weight is 50 calcium carbonate and divided by 61. So the final value will also get in terms of mg per liter. So this is the formula for total alkalinity, and when we will use this formula, we will use this formula when pH is less than 10.2, because when pH is less than 10.2, alkalinity will be caused due to both carbonate and bicarbonate ions. Now coming to the next topic, that is what are the causes of alkalinity. So alkalinity in water causes scaling, second is incrustation, and the third one is bitter taste. This scaling phenomena is similar to tuberculation only, and when the pH of water increases, then there is certain bitter taste that comes to water. Okay, health wise there is no problem, only the taste of water will change. Now how to measure this alkalinity we will see in the separate video, that is the next video, because there is certain relationship that we have to discuss. So this is all about the alkalinity.